Okay, in chapter 7.2, we're going to be graphing linear equations, and we're going to start by graphing these by plotting ordered pairs, similar to what we did in the previous section. So technically there's an infinite amount of ordered pairs that satisfy a linear equation with two variables. So what we're going to do is we're going to find a certain amount of ordered pairs. So we can choose as many x or y values as we want to. Typically the question will tell us what ones to use, and we're going to plug in that value to find the other variable value to complete the ordered pair. We're going to plot those ordered pairs and connect them using a straight line. So technically, when it's a straight line, any linear equation, you need only two ordered pairs, and then you can just connect them with a straight line, and that would technically work, although the instructions for some of these questions will be more than two ordered pairs just for practice. Okay, so let's graph x plus 2y equals 7 by selecting integers for x, starting with -3 and ending with +3. So what that means, starting with -3 and +3 for integers, it's going to be -3, -2, -1, 0, 1, 2, and 3. So we're going to use those x values to find their y values, and then plot their ordered pairs and connect them. So we kind of have two options here. We can use this equation that we're given, or we can solve it for y right now, knowing that we're looking for y for all of these values. So if we solved this for y, we would end up getting y equals 7 minus x divided by 2, right? So we would have to subtract x on both sides and then divide both sides by the 2 that was multiplying the y. So if we use this, we can just plug in the x's and evaluate. So let's do a couple of these. I'm not going to do all of them. Let's say we start with x equals -3, and let's plug it into that formula. So it's y equals 7 minus x over 2. So if you didn't want to do it this way, I personally think this way is a little bit easier because you already have it solved for. You would just plug it in the original one, plug in for x, and then solve for y. Okay, so we have x equals -3, so plugging in a -3, that's 7 minus -3 over 2. That's going to be 10 over 2, which is 5. So that gives us a y-coordinate of 5. So that's going to be the ordered pair -3, 5. So we can plot that. We go 3 to the left and up 5. That'll be right here. Okay, and let's do -2. I'll probably do 3 of these, and then I'll just fill in the other ones. So for x equals -2, so same thing, let's plug it into the solved form. So it's going to be 7 minus 2 over, 7 minus -2 over 2. So that's going to be 9 over 2. So 9 over 2 is 4.5. You can leave it as 9 over 2 or write it as 4.5. You're probably going to want to write it as 4.5 though to help you know where it is when you graph it. So this is going to be the ordered pair -2, 4.5. So to the left -2 and up 4.5. And let's do one more here where we're showing the work, and then if you wanted to test the other ones when I fill them out. So plugging in a -1, we have y 7 minus x over 2. So 7 minus -1 over 2. That gives us 8 over 2, which is 4. So this is going to be a y-coordinate of 4. So an xy ordered pair of -1, 4. So that's going to be this coordinate right here. So hopefully you can tell when you're plotting these points that it's a straight line. And we're told that it's a straight line because it's a linear equation. We also know it's a linear equation because both of the variables have a 1 for the exponent. That's what makes it linear. Okay, so if we were to keep on filling these in, the values we'd get here would be 3.5, 3, 2.5, 2. And hopefully you can see that pattern. I was just subtracting 0.5. There's a reason for that, and we'll get into that, I believe, in the next section. So I'm just going to fill out these ordered pairs. So we get all of these ordered pairs, and if we graph them, we're going to get something like this. And 3, 2. So now all we have to do is connect those dots as a straight line and put arrows on the end. And that is our line. And we can label it, that's x plus 2y equals 7. So essentially the rest of the filled in lines just represents the infinite amount of ordered pairs that we did not plot. Once we see the pattern, we can just fill in the rest of the curve. Okay, for the next one, we have 4x minus 5y equals 20. We're going to graph it by plotting several ordered pairs. So we know it's going to be a straight line because it's a linear equation, because the x and the y both have a exponent of 1. So it says by plotting several ordered pairs. So I'm just going to choose -2 to +2 for the x values. So typically you choose x values to plug in to find y, because x is usually the input and y is the output. And the technical terms would be x is the independent variable and y is the dependent variable. Y depends on x. Okay, so once again for this, what we could do is we could solve this for y first and then plug in these values of x to get the xy ordered pairs. So let's do that up here. So if we solve this for y, we would have to, I would add 5y to both sides, subtract 20 on both sides, and then divide both sides by 5. So I'm just going to skip those steps because technically we should know how to do that. And we would get 4x minus 20 divided by 5 equals y. So now we can just plug in these values and for x and find their y value. Okay, so I'm just going to do like 2 of them just because it's pretty similar to what we just did. So for x equals -2, using this formula, y equals 4x minus 20 over 5. And plugging in the -2, 4 times -2 minus 20 over 5. That's going to be -8 minus 20 over 5. So -28 over 5, which is -5.6. Okay, so kind of nasty, but that's all right. So it's -5.6 for the y-coordinate, ordered pair -2, -5.6. And let's just do one more, and then if you want, you could pause it and test out the other ones, and I'll fill in the other ones. So for -1, same thing, 4x minus 20 over 5. And that's going to be 4 times -1 minus 20 over 5. So that gives us -24 over 5, which is -4.8. So that's the y value here, and the xy ordered pair, -1, -48. So if you wanted to test these other ones, I'll just fill them in. So these are the other coordinates that we get, the other ordered pairs. And notice that the y values are increasing by 0.8 each time. Okay, so plotting these, we have -2, -5.6. That's going to be down here. and obviously kind of messy with the decimal, but that's all right. And then -1 comma -4.8 is down here. 0 comma -4 and 1 comma -3.2, 2 comma -2.4. Okay, so it looks like we did it correct because it looks like it's a straight line, so we just connect them and we label it, and that's our final answer. Okay, so to the next thing for the x-intercepts. So the x-intercept of a graph is going to be the x-coordinate of a point where the graph intersects the x-axis. So as a coordinate, as an ordered pair, I should say, there we go, the ordered pairs, it would be x comma 0, so x is the x-intercept, and y is always equal to 0 for the x-intercept. Okay, and then for the y-intercept, it's going to be the y-coordinate where it intersects the y-axis. So it's going to be the ordered pairs 0 comma y. So x equals 0 for the y-intercepts. So x-intercepts where it's crossing the x-axis, y-intercepts where it's crossing the y-axis. So let's use this graph of y equals x plus 3 to find the x-intercept and the y-intercept. So the y-axis is the vertical axis. So we want to see where it crosses. So the y-intercept is going to be right here at y equals 3. Okay, so as a coordinate, that would be the coordinate 0 comma 3. For the x-intercept, we look at the x-axis and see where it's crossing. It's crossing right here at -3. So the x-intercept is x equals -3, and as an xy ordered pair, it would be -3 comma 0. So one way you could find if we had an equation, which I believe we'll do in a second, if you find the x-intercept, you can plug in y equals 0 and solve for x, and then vice versa for the y-intercept. So let's do that right now, which is what I just said. So using the intercepts to graph linear equations. So the intercepts are pretty convenient to use because we're plugging in zeros. So anytime you plug in 0, things simplify nicely. So to use the intercepts here, we only need 2 points, right, to graph a linear equation. So we can find the x-intercept and the y-intercept. There's going to be one of each for a linear equation. We can find the x-intercept by setting y equal to 0 and solve for x. And we can find the y-intercept by setting x equal to 0 and solve for y. Once we get those, we can plot those ordered pairs, draw a straight line through them with arrows at the end. Okay, so let's do this example. So graph using intercepts, 2x plus y equals 4. So let's find the x-intercept first. So if we're finding the x-intercept, that means y is going to equal 0. So 2x plus y equals 4. We plug in a 0 into y, and we get 2x equals 4. Divide both sides by 2, we get x equals 2. So there is our x-intercept. We can write that as a coordinate if we want. It would be 2 comma 0, but you don't have to. And now for finding the the y-intercept, that means x is going to equal 0. So 2x plus y equals 4. Plug in a 0 into x. 2 times 0 plus y equals 4. That just leaves us with y equals 4. So if you want to write that as an ordered pair, it would be 0 comma 4. And now we can just plot those points. So the x-coordinate, the x-intercept of 2, the y-intercept of 4, and then we connect them. And we get that, and we can label it 2x plus y equals 4. Okay, so that was pretty nice because we just need those 2 coordinates where we plug in zeros. So let's do another one here. we have y equals negative 3/2 x plus 1. So finding the x-intercept, which once again means y equals 0. So we have our equation, negative 3/2 x plus 3. And we're going to plug in y equals 0. So 0 equals negative 3/2 x plus 3. I'm going to add 3/2 x to both sides, so it becomes positive over here. And now we multiply by the reciprocal of 3/2. So multiply both sides by 2/3. That's going to give us x equals 2. So that's just solving a linear equation, which we already should know how to do. So that gives us the x-intercept as an ordered pair, 2, 0. Now for the y-intercept. The y-intercept means that x equals 0. So we're going to plug in a 0 here into y equals negative 3/2 x plus 3. So plugging in a 0 into x, that's actually going to cancel that whole first term on the right-hand side, and we're just left with y equals 3. And as an ordered pair, that would be 0, 3. So we have our y-intercept at 3, our x-intercept at 2, and then we connect them. And we get something like this, and we just label it as y equals negative 3/2 x plus 3. Okay, so that's the graph for that one. And then we have 2 more small things now. So the equation, we'll do the equation of horizontal lines and then the equation of vertical lines. So these ones are going to be the easiest graphs that we'll ever graph. The equation of a horizontal line are going to be in the form y equals a number, and that's it. So y equals b, where b is the y-intercept of the line. These are actually called constant functions. So you can see down here in this little representation, this little graph of it, it's just a horizontal line at that y-intercept of b. So this just means that y will always equal that number no matter what x is equal to. So for example, let's graph y equals 3. So all we have to do is recognize it's y equals something. So it's going to be y equals a number. So it's going to be a horizontal line. We go up to 3 for the y-intercept, and we draw a horizontal line. And that's all we have to do. Easy as that, y equals 3. So y is always 3 no matter what x is equal to. Okay, next for the equation of vertical lines, it's going to be the exact opposite kind of. A vertical line is going to be in the form x equals a, so x equals a number this time, where a is the x-intercept of the line. So you can see here in this little representation, we have a vertical line at the x-intercept of a. So x will always equal a no matter what y is equal to. So for example, let's graph x equals negative 2. So all we have to do is recognize it's x equals a number. So we go to that x-intercept of negative 2, and we draw a vertical line and throw some arrows on the end. And that's all we have to do, x equals negative 2. Okay, so let's do 2 more here. So graph the following, y equals 0. So y equals 0, we recognize it's y equals a number, so it's a horizontal line. We go to the y-intercept of 0, which is right here at the origin, and we draw a horizontal line here. So drawing a horizontal line at y equals 0, we recognize that this is actually right on top of the x-axis, right? So y equals 0 is the x-axis. So for the last one, for x equals 0, we know it's a vertical line because it's x equals a number. So we go to x equals 0, which is right here at the origin, and we draw a vertical line. And it is right there. So notice that x equals 0 is right on top of the y-axis. X equals 0 is the y-axis. Okay, so that is it for this section.